Welcome to my channel Sparkle Mind. In this video, we will see the solutions for relation and functions, previous year's important questions and sample paper 22-23 and 23-24 and additional papers 23-24. இந்த வீடியோவில் நம்ம ரிலேஷன்ஸ் அண்ட் ஃபங்க்ஷன்ஸ் தொடர்பான எக்ஸாம் ஓரியன்ட் கொஸ்டின் சொல்யூஷன்ஸ் பார்க்கலாம். Question number 1. இந்த கொஸ்டின் சாம்பிள் பேப்பர் 23-24ல் கொஸ்டின் நம்பர் 33ல் இந்த கொஸ்டின்ஸ் எல்லாம் 5 மார்க் கொஸ்டின்ஸ். ஸோ let n be the set of all natural numbers and R be a relation on n cross n defined by a comma b related to c comma b, which implies AD is equal to BC for all a comma b and c comma d belongs to n cross n. Show that R is an equivalence relation on n cross n. And also find the equivalence class of 2,6. Solution. So we have to prove R is an equivalence relation. If a relation is equivalence, then we have to prove that R is reflexive, R is symmetric, and R is transitive. First we have to check if R is reflexive. For all a comma b belongs to n. N is a natural number. Given a comma b related to c comma d implies AD is equal to BC. Given a comma b related to c comma d if and only if AD is equal to BC. Here a comma b related to a comma b. For all a comma b belongs to n cross n, then AB is equal to BA. AB is equal to BA. Therefore, R is reflective. AB is BA. Natural numbers obey commutative law. Therefore, R is reflexive. To prove R is symmetric, for all a comma b comma c comma d belongs to R, if a comma b related to c comma d, then AD is equal to BC. If and only if BC is equal to DA. Commutative. Which implies CB is equal to DA. Therefore, C comma D related to A comma B for all n cross n. Hence, R is symmetric relation on n cross n. We have to prove R is transitive. Let A, comma B, comma C, comma D, comma E, comma F belongs to A, then A, comma B related to C, comma D and C, comma D related to E, comma F. Then we have to prove that AB relation to EF. First given AB related to CD, which implies AD is equal to BC. Like that, CD related to EF, then we get CF is equal to DF. Multiplying on 1 and 2, we get ADCF is equal to BCDF. Then removing both sides constant common terms CD, we get AF is equal to BE, which is AB relation to EF. Therefore, R is transitive for all n cross n. So we have to already prove that R is reflexive, R is symmetric and R is transitive, hence R is an equivalence relation. Second part. We have to find the equivalence class of 2, 6. Here x comma y such that n cross n, then x comma y related to 2 comma 6. That is x comma y such that n cross n, y is equal to 3 times of x. Y is equal to 3 times of x. Therefore, equivalence class of 2 comma 6 is, we have to choose natural numbers starting with the 1, 1 3, 2 6, 3 9. Like that we have to write 4 comma 12 and so on. Therefore, equivalence class of 2 comma 6 is 1 comma 3, 2 comma 6, 3 comma 9 and so on. Question number 2. If n denotes the set of all natural numbers and R is the relation on n cross n defined by here A comma B related to C comma D, if and only if AD into B plus C is equal to BC into A plus D. Show that R is an equivalence relation. So given A comma B related to C comma D as AD into B plus C is equal to BC into A plus D. So we have to check reflexivity. We can write AB into B plus A equal to BA into A plus B for all A comma B belongs to natural number. Since sum and product of natural numbers obeys commutative property, we get AB related to R related to AB for all A comma B belongs to n cross n. Hence, R is reflexive. Symmetry. Let A comma B related to C comma D. Then AD into B plus C is equal to BC into A plus D. Then we have to change the commodity. AD becomes DA into C plus B is equal to CB into D plus A. Since sum and product of natural numbers obeys commutative property, which implies CB, here CB into D plus A is equal to DA into C plus B. Therefore, C comma D related to A comma B, hence R is symmetry. transitive. You have to take three elements. Let A, B, C, D, E, F belongs to n cross n. First, let A, B related to C, D and C, D related to E, F. Then by given notation, we get AD into B plus C is equal to AD into B plus C is equal to BC into A plus D. Like that, CF into D plus E is equal to DE into C plus F. So, multiplying both sides and taking like that, we get AB by B minus A is equal to CD by D minus C. That is AB by B minus AB by A minus B is equal to CD by C minus D. Like that we have to multiply here also. CF into D plus E is equal to DE into C plus F. So multiplying and making the required changes, we get CD by D minus C is equal to EF by F minus E. That is CD by taking common minus both side and cancelling, we get C minus D is equal to E minus F. So comparing both, here we get AB by A minus B is equal to CD by C minus D. Here we get CD by C minus D is equal to EF by A minus F. Therefore, AB by A minus B is equal to EB by A minus F. Then cross multiplying EB into E minus B is equal to EF into A minus B and arranging properly, we get BE into A plus F is equal to FA into A plus B, changing AF plus B plus E is equal to BE plus A by B. Therefore, we get AB related to EF. Hence, R is transitive. Since R is reflexive, R is symmetry and R is transitive, R is an equivalence relation. Question number 3. This question is CBSE additional paper 23-24. X is equal to given 0, 2, 4, 6, 8. P is relation on X defined by P is equal to 0, 2, 4, 2, 4, 6, 8, 6, 2, 4 and 0, 4. Based on the above information, two statements are given below. Assertion A. The relation P on set X is a transitive relation. Reason R. The relation P has a subset of the form A, B, B, C, A, B, B, C, C, A. B, C and A, C where A, B, C belongs to X. If both A and B are true and R is correct explanation for A, put A. Both A and B are true but R is not correct explanation for A, put B. A is true but R is false, put C. If A is false but R is true, put D. In this question, A is false but R is true. That is, assertion is false but R is true. Therefore, answer is D. How? Explanation is here. Given. The relation P on set is a transitive relation. Is here they are given this is a transitive relation. If transitive relation 0, 2 related to 2, 4 and 2, 4 related to 4, 6, then 0, 6 related to R. But in this 0, 6 is not belongs to R. See the set. Here we have no 0, 6 that is not belongs to P. Therefore, it is not obey transitive. Hence, or is not transitive. Reason. The relation P has a subset of the form AB, BC and AC, where ABC belongs to X. Take the elements given in the set 0, 2, 2, 4, 0, 4 has a subset of the form where 0, 2, 4 belongs to X. 0, 2. Here this one is A, here B. Here B is the starting part, next one, this is C. Here A, C. Therefore, reason is true. Hence, assertion is wrong, reason is true, answer D. The earth has, next question. The earth has 24 time zones defined by dividing the earth into 24 equal longitudinal segments. These are the regions on earth that have the same standard time. For example, USA, India fall in different time zones, but Sri Lanka and India are the same time zone. A relation R is defined on the set, universal set, all people on the earth, such that R is a relation x, y, such that the time difference between two time zones x and y reside in 6 hours. Check whether the relation R is reflexive, symmetric and transitive. Second one is relation or an equivalence relation. Show your work. Solution. So, the given universal setla all people in the earth. So, all people in the earth or is the relation, the different zones. Time difference between the zones is 6 hours. They are given Sri Lanka and India are the same time zone. Like that, USA and India are the different time zones. But difference between the time zone is always 6 hours. First, reflexive relation. To check the relation R is reflexive. You, all people in the earth. Or relation is x, y such that the time difference between the zone is 6 hours. That is x minus y is 6 given. To check reflexive, any zone x belongs to universal, x, x belongs to R. That is reflexive. X, x belongs to R. But difference between here they are choosing x minus y is equal to 6. Here x minus x is equal to 0 only. Therefore, it is not equal to 0. Hence, R is not reflexive. We know that Any number difference, any number 2 minus 2 is equal to 0. Take any numbers. 6 minus 6 is equal to 0. But not equal to, difference between the same number is not equal to 6. So, or is not reflexive. To check symmetry. For any numbers, x comma y belongs to universal set. X comma y belongs to R. We have to prove that y comma x also belongs to R. It is symmetry such that x minus y is equal to R. 6. Here x comma y belongs to R means difference between x minus y is equal to 6. If y comma x belongs to R now, y minus 6 also 6. Hence, whenever the time difference between x comma y is 6 hours, then the time difference between y and x also 6 hours. That is, R is symmetry. Let x is equal to 12, y is equal to 18. Therefore, we get x minus 12 is equal to 12 minus 8 is equal to minus 6 இருந்தாலும் the time in the we have to take positive 6. Like that, y minus x, 18 minus 12 is equal to 6. So, it obeys or is symmetry. To check transitivity. For any numbers or any zones belongs to the universal x comma y comma z belongs to the U such that x comma y is related to R and y comma z also related to R, then we have to prove that x z belongs to R. That means x comma y related to R. Therefore, the time difference between them is 6 hours, x minus y is 6. Given y comma s belongs to R. Therefore, the time difference between y z is 6. But the time difference between x z is not equal to 6. So, using numbers, check x is equal to 12, y is equal to 18, z is equal to 24. We have x minus y is equal to 6, time difference between 6. Like that, y minus z is equal to 6, the time difference. But x minus y plus y minus z is equal to 12. That is x minus y plus y minus z. So we get x minus z is equal to 12. That is not, x minus z is equal to 12. That is not give 6. Therefore, x comma z not belongs to R. Concludes that R is not transitive. Question. If R is equivalence, R must be reflexive, R is symmetry and R is transitive. But here R is symmetry only. Hence, R is not an equivalence relation. R is not an equivalence relation. Next question, question number 5. A function f such that r minus 1 1 relate to r is defined by f of x is equal to x by x square minus 1. Check if f is 1 1. Check if f is on 2. Show your work. F is 1 1. We have to prove that f of x is equal to f of 5. Assumes f of x is equal to f of 5. Let x by x square minus 1 is equal to y by y square minus 1. And making cross multiplication and rearranging like that, we get xy is equal to minus 1 and x is equal to y. Let us take x is equal to 1 by 2, then y is equal to minus 2. For reason xy is equal to minus 1. Therefore, 1 by 2 into minus 2 we get minus 1. F of x is equal to x square minus 1. F of y is equal to y square minus 1. Using x is equal to 1 by 2, we get f of x is equal to minus 2 by 3. Similarly, put y is equal to minus 2 on f of y. We get f of minus 2 is equal to minus 2 by 3. Here we get f of x is equal to f of y. When x comma y is equal to minus 1 and using x is equal to y, another result. Here x is equal to y. Then put x is equal to y here, we get y square is minus 1, y is root of minus 1, negative is not possible, only imaginary only, hence f is not 1 function. Though we get f of x is equal to f of y, here x is equal to y, x1 is equal to x2, we did not get y square, not possible. Y square is equal to minus 1, only imaginary value. Given here or minus 1 and 1. Except minus 1 and 1. To check f is on 2. Let f of x is equal to y. F of x is equal to, we know that x is equal to x square minus 1. And changing x by x square minus 1 is equal to y. Then we get the value of x in terms of y. Here quadratic equation is x square. Use the formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here a is equal to y, b is equal to minus 1, c is equal to minus y. Solving this quadratic equation, we get x is equal to 1 plus or minus root of 1 plus 4y square by 2y. Here 1 plus 4y square is greater than 0. Therefore, real root exists. And also they are not plus or minus 1. Hence, for any y belongs to R, here y is determined, there x belongs to R, minus 1 domain x is such that f of x is equal to y. Hence, f is on 2. Question number 6. Consider f such that r plus is both side minus 5 closed interval, here open interval, infinity, given by f of x is equal to 9x square plus 6x minus 5, where r plus is the set of all non-negative real numbers. Prove that f is 1 1 and onto function, that is f is invertible. Invertible means f is 1 1 and f is on to now, that is f is invertible. Given, we have to prove that f is 1 1 function, that is f of x1 is equal to x2. Now if f of x1 is equal to f of x2, we have to substitute f of x is equal to given 9x square plus 6x minus 5. Therefore, f of x 9x1 the whole square plus 6x1 minus 5. F of x2 is equal to 9x2 the whole square plus 6x2 minus 5. F of x1 is equal to f of x2. Therefore, comparing both sides, we get is of 0. Taking 9 common, x1 square minus x2 square plus 6, x1 minus x2 is equal to 0. Then this one is a square minus b square, therefore a plus b into a plus minus b, that is 9 into x1 plus x2 into x1 minus x2 plus 6 into x1 minus x2 is equal to 0. Taking the common factor here 3 and x1 minus x2, we get 3 into x1 plus x2 plus 2 is equal to 0. That is x1 minus x2 is equal to 0, x1 is equal to x2, we get one result. Here 3 into x1 plus x2 plus 2 is equal to 0. 3x1 is equal to, we get minus 3x2 minus 2. Here x1 is negative. Since negative, since f such that r plus, r is a positive real number, minus infinity to minus 5 to infinity, x should belong to r plus, that is x is always positive. Hence 3x1 is equal to minus 3x2 minus 2 is not true. Is not true. Hence if f of x1 is equal to f of x2, then x1 is equal to x2. Here f is 1 1 function. Check on 2. F of x is equal to y. Therefore, y is equal to 9x square plus 6x minus 1. We have rearranging, solving the, here f of x is equal to y. So, we get x value in terms of y. It is a quadratic equation in x. Here b is, a is equal to 9, b is equal to 6, c is equal to minus 5 minus y. Solving, we had minus 6 plus 6 root of 6 plus y. Taking 6 is common, we get x is equal to minus 1 plus or minus 6 plus y by 3. Hence, x belongs to R plus, that is x is a positive. Hence, x is equal to minus 1 plus 6 plus y by 3. So, y belongs to minus 5 to infinity. It is y is greater than or equal to minus 5. That is y plus 5 is greater than 0. So here we get y plus 6, that is always is greater than 0. So it is positive. Then x is also positive. Hence x is a real number which is greater than or equal to 0. Then x belongs to R plus. Checking for y is equal to f of x. So f of x. Here minus x is equal to minus 1 plus 6 plus y by 3. So using in this formula 9x square plus 6x minus 5. Replacing x is equal to minus 1 plus or minus plus root of 6 plus y by 3 the whole square into 6 into x minus 5. We get on expansion here a minus b the whole square. A square plus b square minus 2ab, where a is equal to 1, b is equal to root of 6 plus y. A square plus b square root cancel off, you get this one. Then on simplifying we get, so everything is cancelled. So we get y, f of x is equal to y. Thus for every y belongs to minus 5 to infinity, x belongs to R, such that f of x is equal to y, hence f is on 2. Since f is 1 1 and on 2, f of x is invertible. And inverse of x is equal to f inverse y. This is the important, note this. Inverse of x is represent f inverse of y is equal to minus 1 plus root of 6 plus y by 3. Question number 7. Let n be the set of all natural numbers and R be the relation on n cross n defined by a comma b related to c comma d if addition here a plus d is equal to b plus c. A plus d is equal to b plus c. Show that R is an equivalence relation. Solution. Given a comma b related to c comma d such that a plus b is equal to b plus c. So we have to prove first reflexive. For a comma b related to a comma b, then a plus b is equal to b plus a. So which is true since addition is commutative on natural numbers. Therefore, R is reflexive. Second, R is symmetric. If a comma b related to c comma d, then c comma d related to a comma b for all a comma b, c comma d belongs to n cross n. Given a comma b related to c comma d, then we get A plus D is equal to B plus C. Then C plus D is equal to D plus A. Addition is commutative on N. Therefore, C A D, A plus D is equal to B plus C. CD related to A comma B. We have to prove AB related to C comma D. R is symmetry. R is transitive. If A comma B related to C comma D and C comma D related to E comma F, for all A comma B related to E comma B and E comma B belongs to N cross N. Let A comma B related to C comma D. A comma B related to C comma D given. We have C comma D related to E comma F. Then we know that A plus D is equal to B plus C. Like that C plus F is equal to D plus E. So A plus D minus D plus E is equal to B plus E minus C plus F. So we get A minus E is equal to B minus F. Therefore, that is A plus F is equal to B plus E. Hence, AB related to EF. Therefore, R is transitive and R is an equivalence relation. Question number 8. Let f such that n belongs to RBF function defined as f of x is equal to 4x square plus 12x plus 15. Show that f such that n belongs to S where S is an invertible, where S is the range of f. Find inverse of f. Solution. F such that n belongs to RBF function defined as f of x is equal to 4x square plus 12x plus 15. We have to prove that n tends to S. S is the range of f. First we have to understand the definition of invertible function. Definition. A function f such that x tends to y is defined to be invertible if there exists a function g such that y tends to x, g of here f of function x tends to y, we have get another function g of function which is y tends to x, such that g circle f is equal to ix and f circle g is equal to iy, then the function g is called the inverse of f and is denoted by f inverse. Thus, if f is invertible, then f must be 1 1 and on 2. And conversely, if f is 1 to 1 and on 2, then f must be invertible. Here given f of x is equal to 4x square plus 12x plus 15. Then f of x is equal to y is equal to, we have to make it a perfect square. For 2x the whole square, 12x splitting in the middle terms and make it a proper arrangement, we get y is equal to 2x plus 3 the whole square plus 6. Here we have to add and subtraction 9 and 3 square minus 3 square. Hence, here 2ab term we get 12x, 2 into a here 2x the whole square, a here 2x, we have to find b. Therefore, b is equal to 12x by 4x, that is 3. So, b is equal to 3. Now, b square is 3 square, we have to add 9, like that we have to subtract 9 plus 15. So, y is equal to 2x plus 3 the whole square plus 6. Y minus 6 is equal to 2x plus 3. Therefore, taking square root, we get root of y minus 6 is equal to 2x plus 3. That is, x is equal to root of y minus 6 minus 3 by 2, where y is greater than 6. Let g such that s to n is defined by g of y is equal to y minus 6 minus 3 by 2. Hence, f inverse exit. So, we have to prove that g circle f of x is equal to, here g circle f of x is I of x and f circle g is equal to I of y. First, LHS g circle f of x. G circle f of x is equal to 2x plus 3 the whole square plus 6. So, substitute in x, we get the value of x is equal to root of y minus 6 minus 3 by 2. The whole square. On simplifying, we get y. Therefore, g circle f of x is equal to y. Then orchestras f circle g of y. So, g of y. Y is equal to, we know that y minus 6 minus 3. Two x plus 3 the whole square plus 6 minus 3 by 2. On simplifying, we get 2x by 2 x. Therefore, f circle g is equal to x. and G circle F is equal to Y, hence F is invertible and F inverse is equal to G.